Okay. All right, so at this point, I've identified all the information. Right, I wrote all this stuff down, and again here, this would be our 4.5. All right, so now I need at this point, we'll just let the calculator kind of do our rest of the calculations for me. Right? So here, for our TI-84, the way this will work is we go to the Stat menu, and I'll scroll over to Test. And notice here, we're going to use, for this particular section, either be a z-test, a t-test, right, when dealing with a mu, right, or a proportion z-test, or one proportion z-test. But that is not in this problem, right? Here we have a mu, so we go down to t-test. All right, and we see we have all of information here has been previously, well, most of it has it, and this is from a different problem here. So here's our, there's either two ways to put this. We can either put it as data or as stats. If I actually had the raw data, right, like I actually had the years for the 49 students that were surveyed, then I can input those individually, but I don't have that information, right? They just give us the summary here, and in this case, I'll highlight stats, right? If I go over the data, it'll ask for what list it's in and a frequency list if we have it, but again, we don't have those values. So stats, all we have is the summary, right? Mu 0, right? So it just kind of combines these kind of, excuse me, it combines the notation here, right? So it's essentially the null hypothesis, 4.5 x bar, right? That's our data. S sub x, right? It should be sub x, but again, just kind of old. The screen, right? The way it looks. So 1.2. Here's one thing. 49. All right, and also here we have three options, right? Where we have a two-tailed test where it's not equal to, the less than, the null hypothesis, that would be the left tail test, and our right tail test. Okay. All right, and if we hit calculate, all right, so we have our, gives us our t-score, right, which here, our t-score 3.5, so the way I interpret that is that it's more than 3.5 standard deviations away from the mean. All right, so that's our t-score, but more importantly, our p-value, the probability of getting this 5.1 if the actual mean was 4.5 is very small, right? The way you interpret this is you move the e to the negative 4 as you can move the decimal place. Four place values to the left. So this p-value is in fact 2, 3, 5, and I think that's, we can just use one digit there, right? Since it's already really small, right? So I don't really lose much of what I'm aiming for by just simply using one place value here. In reality, what I'm going to compare it to is my alpha value, my significance value, which is 0.01. And we can clearly see that the p-value is much smaller, right? So what that tells me is that this result of 5.1 is incredibly unlikely. Right? It has less than it's a 0.5% chance of happening if the population mean was 4.5 years. So I am comfortable here with accepting this type 1 error by rejecting the null hypothesis, right? So the significance level, again, we're not eliminating the error, right? All we're doing is we're saying I'm comfortable enough with that with the error, the type 1 error that I will receive by being incorrect by rejecting the null hypothesis, right? Based off my results here. So we reject the null hypothesis. So now we have to summarize, right? So here, at the end of the problem here, it's up to us to determine, explain what our decision is, right? So reject the null hypothesis, right? And the reasoning for that is because the p-value is less than the alpha value. All right, so our summary here is that there is enough evidence for us at the 1% significant level to reject the null hypothesis. All right, so I feel confident saying that mu is greater than 4.5. Okay, now again, attention to that, right? Mu is not 5.1 like our sample had suggested. In fact, I have no idea. That's a whole different problem, right? All we're saying is that mu is definitely bigger than 4.5, right? If I'm at the 1% confidence significance level, right? That shouldn't say much, it is larger than 4.5, right? That is all that I can say. I don't know what the population mean is. I just have established that it is larger than 4.5 years. Okay, thank you.